Hi Grade 8! I'm Teacher Joshua, your mathematics learning guide here at DepEd TV. How can you use one variable to solve a system? In this lesson, we will apply our knowledge in expressing a variable in terms of another as we explore a new way to solve systems of linear equations. So buckle up, get your self-learning module, pen, papers, and ready yourselves for a challenge ahead. Last time, we learned that we can solve a system of linear equations by graphing. And the solution to a system is the point where the lines intersect. But when the lines are parallel, the system has no solution, since there are no points of intersection. While a system with coinciding lines have infinitely many solutions. Solving a system by graphing takes a lot of time. And since we need 2 points to draw the line, we usually solve for the x and y intercepts of each linear equation. What we'll learn today is how to manipulate the terms and expressions so we can get the solution to a given system. This is solving a system of linear equations by substitution. Let us use an example that we had in the previous episode. Y equals negative 3 halves x plus 2 and y equals negative 1 half x minus 2. From that lesson, we graphed the system and found that the point of intersection is at 4, negative 4. We will use another way to show that this is the solution to the system. Since y is equal to itself by the reflexive property, we can equate the two. Negative 3 halves x plus 2 is equal to negative 1 half x minus 2. By the addition property of equality, we can isolate the terms with variables on the left side and the constant terms on the right side of the equation. Negative 3 halves x plus 1 half x equals negative 2 minus 2. Now, we simplify by combining like terms. Negative 3 halves x plus 1 half x is negative x, while negative 2 minus 2 is negative 4. And we can multiply both sides by negative 1 such that x will be positive. Thus, x is equal to positive 4. Now that we have the value of x, we can substitute it to any of the equations in the given system to get the value of y. Let us use y equals negative 3 halves x plus 2. By substitution, we will have y equals negative 3 halves times 4 plus 2. What is negative 3 halves times 4? Negative 6. Then we write plus 2. What is their sum? It is negative 4. So again, x is equal to 4 and y is negative 4. These values give us the coordinates of the point where the two lines meet, 4, negative 4. Therefore, the solution to the system without graphing is 4, negative 4. There are times that the system is inconsistent or consistent and dependent. It means that it may have no solution or has infinitely many solutions respectively. So consider this system. X plus 2y equals 3 and 2x plus 4y equals 4. Here's a tip in using substitution. If a variable has a numerical coefficient 1, it is usually the easiest to write as another expression. In this case, the first equation, x plus 2y equals 3, can be written as x is equal to negative 2y plus 3 by the addition property of equality. Next is we substitute the resulting expression to the second equation as the value of x. 2x plus 4y equals 4 will become 2 times the quantity negative 2y plus 3 plus 4y is equal to 4. By the distributive property, we multiply 2 to each term in the parentheses. So we will have negative 4y plus 6 plus 4y equals 4. We need to isolate the terms with variables on one side of the equation and the constant terms on the other side to solve for y. So it will be negative 4y plus 4y equals 4 minus 6 by APE. Now we can simplify this with 0 is equal to negative 2. But wait, this yielded a false mathematical statement. And when this happens, the system is inconsistent and has no solution. You can also check the type of system by getting the ratio of the coefficients of x, the coefficients of y, and the constants before solving, just to confirm if there are solutions or none. This is an example of a consistent and dependent system. Now let us see what it would look like when we use substitution. 3x minus y equals 0 and 3y equals 9x. Again, it does not matter which variable you will choose to be written in terms of the other. The goal of this is to develop your decision-making skills and see if you can plan ahead of your solution. For this case, we will use the second equation, 3y equals 9x, since we can multiply both sides of the equation by 1/3. This will give us y equals 3x. Now, we substitute this to the first equation to have 3x minus 3x equals 0. Then we can simplify it as 0 equals 0. This is a true statement regardless of the value of x or y. This means that the system has infinitely many solutions. Now try this. Find the solution of the system with the equations 2x plus y equals 8 and y equals 1/2 x minus 4. If you have observed, the second equation is in its slope-intercept form, which means we can directly substitute this to the first equation. So we will have 2x plus 1/2 x minus 4 equals 8. By the addition property of equality, we will have 2x plus 1/2 x equals 8 plus 4. Now let us combine like terms by addition. What is 2x plus 1/2 x? That is 5/2 x. Then add 8 and 4 to get 12. How can we solve for x if the numerical coefficient of x is 5/2? We can multiply both sides of the equation by the multiplicative inverse, 2/5. So we will have x equals 2/5 times 12, which is 24/5 or 24/5. Since we already have y in terms of x, we just substitute the given value. So y equals 1/2 times 24/5 minus 4. What is 1/2 times 24/5? This will be 12/5. To add the similar fractions, we need the LCD or the least common denominator of 12/5 and 4. Then make them similar. The LCD is 5, which means we can write this as the difference between 12/5 and 20/5. Can you simplify this? Since the fractions have the same denominators now, we simply subtract the numerators and copy the common denominator. And we will have -8/5. So, the solution to this system is given by the ordered pair 24/5, -8/5. Now, let us use what we know to solve the problem involving mixtures. A lab needs to make 100 gallons of an 18% acid solution by mixing a 12% acid solution with a 20% acid solution. How many gallons of each solution are needed? What we need to do first is to represent this problem using a mathematical model. So imagine that there are two containers, one for the 12% acid solution and one for the 20% acid solution. We do not know the number of gallons of acid there are in each container. So we can let X and Y represent those quantities in gallons. When these acid solutions are mixed, they just add up their volume. So we can say that X plus Y equals 100. Now, we know that the final product should have 18% concentration. So we can say that the second equation is 12% or 0.12 times X plus 20% or 0.20 times Y is equal to 18% or 0.18 times the total number of gallons, 100. We can use the first equation to write X in terms of Y by simply using addition property of equality. So X is equal to 100 minus Y. Then, we substitute this to the second equation. 0.12 times the quantity of 100 minus Y plus 0.20Y is equal to 0.18 times 100. Next is we multiply the necessary expressions. That is 0.12 times 100 or 12 minus 0.12Y plus 0.20Y equals 18. Then we use the addition property and combine like terms. Negative 0.12Y plus 0.20Y equals 18 minus 12. What would be next? This can be simplified as 0.08Y equals 6. What will we do to get the value of Y here? We can divide both sides by 0.08. What will be the quotient of 6 divided by 0.08? The 20% solution must have 75 gallons. How about the 12% acid solution? We just subtract 100 minus 75. What is it? Very good. The other container must have 25 gallons of 12% acid solution. Now, let us check if we got the correct answer by substituting the acquired values of X and Y to the system. Let us use the first equation, X plus Y equals 100. Since in the problem, X is 25 and Y is 75, we can show that 25 plus 75 is indeed 100. But for an ordered pair to be the correct solution, it must satisfy both equations. So we will have 12% of 25 or 0.12 times 25 plus 20% of 75 or 0.20 times 75 equals 18% of 100 or 0.18 times 100. Can you check if they are equal? 12% of 25 is 3. 20% of 75 is 15. And 18% of 100 is 18. Simplifying, we have shown that 18 is equal to 18. Hence, we got the correct solution. Remember that in mathematics and sciences, we often need the exact measurements to avoid mishaps, accidents, and anything that might endanger us or our surroundings. that has been a lot of linear equations that we solve. As we practice, in time, you would feel that solving systems of linear equations by substitution will be intuitive for you. To solve a system of linear equations by substitution, we must express a variable in terms of another. Then substitute the resulting expression to the other equation in the system. Remember to use necessary properties of equality in solving for the values of x and y. Also, the solution to a system is unique if you acquired a value for x and a value for y. When the equality acquired shows a false statement, the system has no solution. But when the equality gives a true statement, usually in the form of 0 equals 0, then the system has infinitely many solutions. I know that you have learned a lot in this endeavor of solving systems by substitution. Now let us see and evaluate what you have learned. You have 5 seconds to answer each item, so prepare your pen and paper with you. Number 1. What is y equal to if 2x minus y is equal to 1? A. Y is equal to 2x minus 1. B. Y is equal to 2x plus 1. C. Y is equal to 1 minus 2x. Or D. Y is equal to 1 plus 2x. By the addition property of equality and the symmetric property of equality, we can show that y is equal to 2x minus 1. So the answer is letter A. Number 2. What does it mean when we arrive at a false mathematical statement when solving systems of linear equations? A. The system is consistent. B. The system is dependent. C. The system is inconsistent. Or D. The system is independent. A false mathematical statement, like 0 equals 1, suggests that the system is inconsistent since it has no solution. So the answer is letter C. Number 3. What can we say given a system with equations x equals y and y equals 2x plus 3? A. X equals x plus 3. B. X equals 2x plus 3. C. 2x equals x plus 3. Or D. 2x equals 2x plus 3. To answer this, we simply substitute x to y. So we will have x equals 2x plus 3, which is letter B. Next question. What is the value of x in the previous system? Is it A, x equals negative 3? B, x equals negative 1? C, x equals 1? Or D, x equals 3? By the addition property, we will add negative 2x to both sides of the equation to have negative x equals 3. Then we will multiply both sides of the equation by negative 1. Hence, x equals negative 3. So the answer is letter A. Last item. What is the value of y in the previous system? A. Y equals 3. B. Y equals negative 3. C. Y equals 9. Or D. Y equals negative 9. If you noticed, x is equal to y. Therefore, y is also equal to negative 3. So the answer is letter B. Did you get them all correctly? I know that you can do it. Keep on polishing your skills and you will be a master of mathematics in no time. If you find the topic difficult, you may consult your self-learning module or visit the DepEd official YouTube channel and review our lessons. Our next episode will be the last lesson for the first quarter. So join me in learning another way to manipulate your terms to solve a system of linear equations, which is by elimination. Because the more we know, the better we can think and consider which method is more appropriate for different instances. With that, this is Teacher Joshua reminding you to practice, do it with a positive attitude and a smile on your face. Keep on being critical, logical, and responsible grade 8 students. See you next episode for a math terrific day here at DepEd TV.